Kia ora boys, this is my first video, so just bear with me. I thought I'd start each video with a thing that I call a raster. You can see raster here, look at that, look at all those awesome colours. Raster, which is a random statistic that's awesome. Today, the raster is that Logitech did this awesome study where they calculated that if you lose your TV remote, there is a 50% chance that you will find it in the couch. There is a 4% chance that you'll find it in the freezer, and there is a 2% chance that you'll find it outside or in the car. There you go. Right, the first question I'm going to do is the excellence question from question 1. It's question 1B, not A. To do it, well, it asks us to find or prove that the trapezium E, G, H, and F is a isosceles trapezium. This over here is our final statement, and these things here are all the things that I'm going to have to find to be able to prove it. So to prove that it's an isosceles trapezium, I actually need to prove that this angle in here and this angle in here are the same, and that this angle in here and that this angle in here are the same. So I'm going to do the bottom two first. The first one I'm going to do is EGH, and that is quite easy. EGH will simply be 76 degrees because of alternate angles in parallel lines. Okay, if you can't see that, this is a Z here to there. Okay, if I draw a thing around that and then a thing around that, that's my alternate. The next one's a little bit harder. The next one I have to, firstly, I'm trying to get to this angle in here, remember? I'm trying to get to that one, but to do it I've got to prove that one, I've got to find that one, then this one, and then I can find that one. So this one up here I will find by using alternate angles again. There's a Z, there's a Z. So HIF will be 76 degrees because again, alternate angles, and I'm just going to do dot, dot, dot in parallel lines. The next one, which is this one here, which is HFI. HFI is going to be 76 degrees because base angles in an isos triangle are equal. Then the last one I need to do is angle FHG. FHG will be 76 degrees because 76 degrees because alternate angles and parallel lines are equal. Now, if you can't see that, see this angle here and this one here, they are a Z and they're on parallel lines. Okay, so that means that we can now say that these two angles in here, this one here and this one here, they are equal. So I can say EGH equals FHG, and I'm halfway there. The next point I need to say is that I need to prove that these two green ones down the bottom here are equal. Okay, so the first one there, that one there will be equal to, sorry, we're going to do the top ones now. This one here will be equal to 104 degrees, simply because of angles on a straight line. So 104 degrees, and that's angles on a straight line. And they're equal. The next point will be this one here, and that again will simply be 104 because angles on a straight line. Look at that. Excuse the atrocious writing, guys. It's very hard to write with this pen. I'm going to have to invest in a new one. Okay, so now that I can say that, I can say that EFH is equal to FEG. Hurrah! So these two things here, that thing there and that thing there, allow me to say that this is an isosceles trapezium. So for an isosceles trapezium, the two top angles and the two bottom angles have to be equal. So I need to write that, and I need to write that. Okay? Is this one here. This one here is question C, or 1C. It's an excellence question, and it involves similar triangles. So I'm going to try and explain why it involves similar triangles. So similar triangles here, if I draw a line here, that's a, or I'll actually show you, this triangle here, there's one triangle, and then this is a triangle here. I'm going to get rid of those lines now, but we've got two triangles, and they share the same angles. That angle there is x. Oh my goodness, that doesn't even look like an x. That angle there is an x. This angle in here I'll label y. It's the same angle as that one there. Because they've got the same angles, here and here, and here and here, it's a similar triangle, or they are similar triangles, and therefore they're in proportion to each other. I'm going to try and get rid of all that. Look at that, magic. So because they're similar triangles, I can use ratios to figure out that this side here and this side here will be proportionate to each other, and then this side here and this long side there will also be in proportion to each other. Okay, so to write that out, you start by going the short side. So I'm going to go the short side, or the red side I should say, over the big triangle's red side, and that is going to be equal to the small triangle's green side, which in this case will be x, we don't know how big that is, and the all over the big triangle's long side or green side. Now that green side, if that's x there, and this is 48, the long side will equal x plus 48. Guys, that's probably the hardest part of this question, although the algebra can be a little bit daunting, and that's what we're going to work on now. So the first thing I need to do, if I just slide, remember we've got 57 over 133 equals x over x plus 48. That's what we got from the last slide. I'm just going to do the algebra here. So the first step is I need to get rid of that 133. To do it, I need to times that by 133, because the 133 is dividing the 57. I do the opposite of it. So I'm timesing to get rid of the dividing. I'm going to times that by 133 as well, because whatever I do to one side, I need to do to the other. Okay? So that will get rid of that, and I'll be left with 57. In fact, I'll stick with the same colours. Get rid of that. So 57 equals 133x, still over x plus 48. Now the same process applies. I'm going to try and get rid of that. To do that, I need to times it by x plus 48, because currently the x plus 48 is dividing that, so to get rid of it, I multiply. But whatever I do to one side, I need to do to the other, so I'm going to times that by x plus 48. Hurrah. Making sure that I times both the x and the 48 by 57. So that will give me 57x. Come on, Mr. Perkins, use the right colours. Here we go. 57x plus, it'll be 2,756 equals 133x now. Now I need to minus this thing here, 57x off that, so I'm left with just a number here. That will be 2756 equals 76x. What I've done there, guys, is I've minused, that'll go, and I'm going to minus 57x off that. And I'm left with 76. Final step, I can divide that by 76, because that's timesing. Divide that by 76, and I will be left with 30. Boys, I can't remember. Is it 38? I think it's 38. No, it's not. I think it's 36. Whatever it is, guys, just do that on your calculator and you'll figure it out. I think it's 36. Make sure you put meters. Okay? And there's your answer. So that part there is really, it could be the harder part for some of you. That's the excellence part, though. If you've done all that, you get excellence.